So once again, I just wanted to say good evening to everybody and welcome to tonight's webinar from the National Weather Service in Boston. I am Joe Deli Carpini, the Science and Operations Officer, and tonight we're talking about the February 3rd and 4th Arctic blast from this year. Probably the best shot of Arctic air we've had in several years, and we'll talk a little bit about that, put it into perspective, and go through some of the impacts. Really was it was a very quick shot, but certainly one I think we're all going to remember from this winter. Probably one of the highlights of this winter if you're a cold weather fan. So just our overview here as we get started. We did have a brief shot of Arctic air. Remember, it just really affected us on that Friday and Saturday, February 3rd and 4th. It was really the only second period of significantly below average temperatures over the winter. If you remember, we had our first in December, a little bit before Christmas, and that was another brief shot as well. We did have strong and damaging winds accompanying the arrival of the cold air, if you remember. Many reports of some downed tree limbs, even some downed trees. And looking back, this was really our coldest period of temperatures and wind chill since February of 2016. So a good 7 years. I'm sure many of you remember that. That was the winter after our big 6-week snow blitz of 2015, which also featured some cold weather. But that was around Valentine's Day of February 2016. We have a similar shot of cold air. And the models and ensembles really did a good job highlighting this potential nearly a week ahead of time. And that really helped us, not just with the messaging of the event, which we started the Monday before, January 30th, but really gave our forecasters confidence in realizing this was going to be a pretty significant weather event for us, not just the cold, but the wind, and as I'll show you, even some of the marine impacts. All right, so we're going to have a little fun here tonight. I always like to do some poll questions, and this is for our cold weather fans, maybe our warm weather fans. Everyone knows the heat miser and the cold miser. So I'm going to put up some poll questions just to get us started here. And our first question is, which character is most like you? And I think this is probably a loaded question, but let's see. Well, I'll let the votes come on in. Are you a cold miser? Are you kind of disappointed this winter, but you were kind of happy for this one weekend where we had some really good Arctic air come in? Or are you kind of a heat miser where, this winter's been pretty good. I could take more of these where it's 40s and 50s and maybe just a brief shot of cold. So let's see. The responses are coming in. I will show the results in a second here. Not much of a surprise that cold miser is winning out, but the heat miser is making a late run here. Let's see. All right. I'll give it a couple more minutes, and then I will be able to show you on the screen. Okay, I think we've got everybody in there. So I'm going to close this, and let me share the results. I hope it'll work. Here we go. So 70% of you are cold misers, which I kind of figured. So bring it on. We want to see, I think you're going to want to see a cold March. And for the rest of you, 30% in the heat miser, like the hot and humid. And I gotta say, I'm more in the heat miser lately. I used to like the cold, but then I went to school in Oswego, New York for 4 years, and that was enough. So let me go back here, and let's go to our next poll. So for those of you, I'm sure you all remember this. What temperatures? How cold did it get where you are on that Saturday? February 4th at your location. We're near zero. Maybe you lived down there the south coast. It was actually a lot of places went below zero. Maybe you were 0 to 5 below, 5 to 10 below, or colder than 10 below. And if you have a home thermometer, I'm sure many of you do, or just kind of take a guess. That's fine with me. Looks like so far the colder than 10 belows are winning out. We'll keep it going. For me, at my location, I was right at 10 below zero, so that was a pretty good shot of cold that morning. Let's see. I know many, even down to the Cape and the Islands, it got below zero, which is pretty unusual. So let's see. The responses are calming down. So, okay, I will close this and show you the results. So you can see here, most of it, 45%, colder than 10 below. That's pretty good. And yeah, I would agree. I think most of here in southern New England was colder than 10 below. 5 to 10 below zero came in at 41%. That makes sense as well. That's, the areas near the south coast, maybe Providence in that area. And the 0 to 5 below, about 14%. So that's the Cape and the islands, immediate south coast. It was a little bit milder there as well. So yeah, good to know. I figured most would be colder than 10 below, but always good to ask. All right, and we'll go to our last question here. And again, probably a loaded question, but I'll ask it anyway. What do you want to see for our weather in March? Do you want to see the snow and cold because it's been a dull winter so far? Do we want to end on a bang here in March, or are you ready for some warm weather? Let's bring on the spring. Let's see. And again, I know these are loaded questions, but that's okay. Look, it's actually pretty close. I'm kind of surprised. Let's see. As we're coming in, snow and cold is winning by a little bit. Currently we're at about 55 to 45%. So let's see. Yeah, it looks like the poll is complete. So I will show you the results here. And there we go. So the snow and cold wins with 55%, but not far behind as the warm weather folks bring on spring. And yeah, so we're actually not too far away. So we'll kind of see what happens here as we get into March. And like I said, this is definitely our most active week of the 2022 and 2023 winter. So, all right. So I will close that. We will move on and start talking about this event a little bit more. So here's a look at our low temperatures for both Friday, February 3rd and Saturday, February 4th. And keep in mind, the Friday low temperatures were pretty much right at midnight Friday night going into Saturday morning. So you can see Boston was down to a -8, Providence -4, and Worcester was down to -10. And these are the records. So Hartford didn't set a record that night, but all four sites, our climate sites, did set records Saturday morning. You can see Boston got down to -10, which was the first time it reached that since January of 1957 when it was -12. That's pretty impressive. Providence and Hartford both 9 below, and Worcester down at 13 below. So again, this was really the coldest weather we've seen since February of 2016. So even down on our friends on Nantucket, this was pretty impressive cold. And Bill, our climate guy, as you probably know, looked up some records for us. And the low of -3 at the airport on Nantucket actually tied the record for the all-time record low temperature in Nantucket set in 1962 and 2004. And it was the first time going back in our records we've ever issued a wind chill warning for Nantucket. And that's a relatively new warning, but it's been around long enough, and that's pretty impressive to see. And wind chills did top out nearly at 30 below on Nantucket with those strong winds. So definitely impressive cold. Now, as far as the wind gusts, many reports, it might be hard to see some of the numbers here. These were in miles per hour. Many reports of 50 to 60 miles per hour. Some of the higher reports stand out in red. We've got a 61 here in the Berkshires, 62 at Worcester Airport. On the south coast, you can see several reports over 60 miles per hour. This is the Buzzards Bay entrance tower of the buoy. We've got a 69 on Cape Cod. So, yeah, there were definitely some higher gusts for the most part between 50 and 60 miles per hour. You can see some of the higher gusts there on the right. So that, accompanied obviously with the very cold air, not only produced damage, but dangerously cold wind chills that we haven't seen in some time. And from the winds, also power outages. Most of the power outages we noticed were in Massachusetts. This was a snapshot around 8 p.m., reporting about 45,000 customers without power. And you can see kind of where the hot spots were. We've got some areas near the Berkshires, mostly in the higher elevations, but there was a little cluster here on the South Shore around Braintree and the South Shore communities where they had a little more in the way of power outages. So definitely, it was an impactful event, not, hundreds of thousands without power, but certainly, the 45,000 people without power didn't have heat as well. And that was certainly a concern, getting this power restored while there were still gusty winds going on. So fortunately, I don't think these lasted very long at all, but in that dangerous cold, you don't want to be without power for too long. Now, there were also some marine impacts from our friends at the Steamship Authority on February 3rd at 5 p.m. All trips were essentially suspended at 5 p.m. Those were the last ones of the evening, and the Nantucket route has been canceled on the day for the entire day on February 3rd. And then on the next morning, they actually had some issues with frozen pipes on the vessels. 3 of the vessels running the Martha's Vineyard route actually had burst water pipes and a leak in hydraulic lines. So they had to suspend service for part of the time during the morning before another vessel could be brought into service. So again, even the extreme cold affected a lot of the marine areas as well. And something else with the marine that we saw was Arctic sea smoke. And, it's a common feature when we get these Arctic air masses coming over. We had many pictures sent to us from around the area. You see on the right there, the ferry coming into Vineyard Haven on Martha's Vineyard. On the left is Boston Harbor. And it forms, when the temperature difference between the Arctic air mass and milder water is kind of extreme. And I always say it's like opening the freezer on a hot day when you see the kind of the smoke or steam coming out of the freezer. It's the same process here. So it can be a little bit of a hazard for marine traffic because it lowers visibility, but it usually, will burn off during as the heating gets going during the day. It's typically during the morning hours is when you see it, when the winds are light. And then another phenomenon, this is really kind of neat. We had John Costello sent us these photos. He was actually on approach landing in Boston on a flight to Logan Airport. These were off Nantucket Beach in Hull. And we have two things called steam devils and waterspouts. You're probably familiar with waterspouts, but these steam devils occur. They're similar to waterspouts in Arctic air, but the funnel isn't as deep or as strong to be attached to the cloud. So it's just kind of like a whirl in the water. And above the photos here, you can see we've labeled them. You can see these smaller, shallow circulations or steam devils. And this is more of a waterspout. You can see there is actually a little bit, it's hard to see, but there is an attachment all the way to the cloud. And you can see here on the right as well, these are more steam devils. There's no cloud above. They're just some swirls that are in the water. So interesting phenomenon. I don't think I've ever really seen the steam devils captured by photography before with these Arctic air masses. Usually just a lot of Arctic sea smoke. So pretty cool. And we thank John for sending those photos to us. All right. So the one thing that was really impressive to me was the extreme icing that occurred from freezing spray. This is not typical of southern New England. This was more typical of the Bering Sea. And if you're fans of, say, like Deadliest Catch, you're probably familiar with this. These icing rates you're seeing on these buoys, Mass Bay nearly 1 inch per hour, Nantucket Sound over 2 inches per hour, and Nantucket Shoals offshore about 2 inches per hour. That's a lot of icing for a vessel to take on. And you can see those easily fall into the heavy or even extreme rates of icing from freezing spray. And just as a quick review, freezing spray forms when our air temperature is below the freezing temperature of seawater, which is about 28 degrees Fahrenheit. You need winds of 18 knots or higher. And the lower the air temperature and the stronger the wind, the more rapid ice buildup occurs. And it's most common in our waters in January and February. That makes sense because our seawater is typically at its coldest, and we tend to get these Arctic outbreaks during January and February. So why is it dangerous? Well, on the left here, you can see as the ice builds on the vessel, its ability to right itself decreases. So if too much weight is added, the factors that typically right the boat aren't strong enough to reverse the roll, and the vessel will capsize. And every new layer of ice creates more surface area for the next layer. So the weight increases exponentially, increases very rapidly. So what has to be done is the ice has to be removed as quickly as possible. So it's also, the danger is just more from the added weight. It's the uneven distribution over the hull of the vessel, which makes it even worse. So a lot of times what will happen is use sledgehammers to take the ice and get it off things like the superstructures, the rigging, and the decks as well. And there were, back in 2008, we had a fishing vessel, Lady of Grace, which sank in Nantucket Sound from heavy icing, and it occurs quite a bit up in the Bering Sea. So really the only thing you can do is either not, get into port or take immediate measures to kind of clear the ice. And this was a situation, fortunately, I don't believe there were many vessels out there. It was well forecast, and it really, fortunately there was no loss of life from this at all. But certainly it's something we deal with every once in a while here in the southern New England waters. Okay, so let's talk about the source of the Arctic blast. Where did it come from? Well, yes, the Arctic, but we can actually prove it. We have a model that NOAA runs called the high split model, and we can run what's called backward trajectories. We can see where our air came from over the past few days. And typically this model is used to forecast dispersion of smoke and other pollutants, things like forest fires. It's used to kind of tell where the smoke is going to go, or even, like I said, pollutants. But in this case, we can run it backwards and kind of see what happened. And you can clearly see the air here over southern New England had its origins up near the Arctic Circle. So no question that this was a true, Arctic air mass for us, over a quick one, but it certainly came right down from the Arctic Circle. Now, what about the effect of snow cover? There was a lot of conversation about this beforehand, and even though at this point, this is a February 4th snow depth map you see here, there's not a lot of snow cover in southern New England, a little bit in the north, but this is actually was pretty much below average. There was extensive snow cover across Canada, the Northern Plains, the Great Lakes, so that really prevented the air mass from modifying or warming or losing its true cold as it tracks south. So, but really the key here, and I'll show you in a minute, are 850 millibar temperatures, or temperatures around 5,000 feet. They were colder than minus 30 Celsius. So the snow cover really played just a minimal and negligible role here. The air mass was so cold to begin with, it didn't matter if there was snow on the ground or not. Typically, this is more important when we have I would say a quote unquote milder air mass coming down to look at things like low temperatures. But in this case, the air was just so cold, it really didn't make much of a difference. So let's take a look at the air mass. And this was a nice social media post from our friends up at the Gray, Maine office showing their evening sounding. This was 7 p.m. on Friday, February 3rd. And you can see this is cold. It's almost off the chart here on the left. And for those of you who may not be familiar with the soundings, the red curve is temperature, the green curve is dew point. So we're going up in the atmosphere as the balloon is tracked. So what you're seeing is temperature starting off, colder than minus 20 Celsius. And in fact, the top of the troposphere, which is where our weather occurs, was all the way down to about 795 millibars, or just a little higher than 5,000 feet in this case, which is very unusual. Usually the troposphere, tropopause is up, 30, 40,000 feet or higher. But the air mass is so cold that it came down to be that low. And this is all stratospheric air up above. And you can see Mount Washington is only a little bit higher than that. So, was Mount Washington in the stratosphere? Probably, because the troposphere was below the summit. So that's pretty cool. And, again, an extreme example, but this is what happens in these really cold air masses. The tropopause, or where our weather occurs, lowers significantly. In this case, the Gray, Maine sounding, it was a little higher than 5,000 feet. Now, the one thing you also have probably heard about were the wind chills on Mount Washington. They had a wind chill of minus 108 Fahrenheit Friday night, and that set a new record for the lowest wind chill in the United States. The previous records are listed there, minus 105 in Alaska. And then at Mount Washington in 2004, it was minus 102.7. So this was definitely the coldest wind chill in the United States. All occurred at Mount Washington. Okay, so we also had a sounding shared to us from McGill University up in Montreal, just to show that, yeah, this was really this cold. And they did a couple of soundings, one at the afternoon at about 1:30. And again, these 850 millibar temps that we're keying on about 5,000 feet, minus 38 Celsius, and then a little bit colder, almost close to minus 39 Celsius at 4 o'clock in the afternoon. And again, notice how low the tropopause is. It's down, 5,000 feet or below in some cases. So definitely a record cold air mass that occurred in this time. So how about the messaging? Well, as I mentioned, the models did a really good job out on the longer ranges. We kind of saw this coming, maybe not to this extreme, but we saw it coming. And our friends at the Climate Prediction Center did note a risk of hazardous cold temperatures during that week, a moderate risk, especially in northern New England, and a somewhat lesser risk farther to the south. But this was on January 26th. So that's pretty good, looking out 8 to 14 days and be able to key in on that. Now, as far as forecasting this event, we like to use what we call the situational awareness table, and it's comprised of the North American Ensemble Forecast System. That includes both the American GFS ensemble and the Canadian ensemble. So it's kind of putting the two right together. That's why we call it it's called the NAEFS, or the North American Ensemble Forecast System. And this table did show some early signs of a significant cold outbreak as early as January 26th. You can see down here in the boxed area, you can see temperatures are getting lower than normal. Not extreme, but you can see something's there. And also, as we talked about, the 8 to 14 day outlook also showed pretty high probabilities, especially over the Great Lakes, and eventually that would translate east here into New England. Now, if we move up in time, this was January 31st, looking at the same table centered over southern New England, and you can see now things are kind of off the charts. Look at our T, the temperature column. These are percentiles, so it was at the lowest, the minimum for the model climatology at this point for the 3rd and the 4th. Also note the really dry air, too. That's a good sign, of a very cold air mass. It's also very dry, but if you were to click on one of these, you would see where the cold air was located. This was at 1 a.m. on Saturday, February 4th. And you can see by then the heart of the cold air mass was kind of already retreating. You can see the coldest air, minus 36 Celsius, is up in northern Maine. And you can kind of make the sense that this has already rotated through. So we were already past the coldest air aloft at that point. And that meant that on Saturday, we actually would start to see, a recovery, and especially Saturday night into Sunday, there was a pretty rapid warm up that occurred. So now I want to just show you kind of what happened, the evolution. And this is at 500 millibars, about 18,000 feet. And this is our steering flow for weather systems. So as you can see, as I'll let this go through once, and then I'll start to key in on the features here as it loops. This is looking at the analysis from January 31st all the way to February 5th, to kind of show the evolution. As it starts again, you can see our piece of the polar vortex. It's been there for a lot of the winter. Our subtropical ridge has been giving us warmth for much of the winter. But notice this piece that comes down across the northern plains into the northern Great Lakes and eventually phases up with this other wave here in the southern plains and forms into one broad closed low. And that's really our quick shot of cold air. And notice how quickly it retreats. It didn't hang around very long because you'll notice over Greenland, there really was no blocking. We don't see a ridge of high pressure. So as a result, as this wave comes around, it's free to exit right off to the coast and into the Maritimes and not hang around very long. If we had a blocking ridge of high pressure here, this would have stuck around quite a bit longer and could have lasted for a few days. So certainly an impressive shot, but I think even more impressive that it was kind of in and out in about a 24-hour period. Okay, so just showing the 850 millibar analysis, again, looking at about 5,000 feet. This is 1 a.m. on Saturday, February 4th. And you can see at that point, that's when the core of the Arctic air mass was over the northeast. I've got to zoom up here on the right. Temperatures were down anywhere from minus 32 to minus 36 Celsius. That's rarely seen. I've speaking with some of the forecasters at our office who have been around here for a while. I don't think we've ever seen this in our area. So that certainly was telling us this was a pretty impressive shot of cold. Now, one thing we can look at is kind of an analysis of different what we call clusters. So what we do is we take the GFS ensemble, the European ensemble, and the Canadian ensemble, and the computer looks through everything and kind of determines, where are they similar, what's dominant in one feature, what's dominant. It comes up with these cluster analysis, it's called. So this is looking at 850 millibars, and you can see here, this is one that's heavily weighted toward the GFS ensemble. Here's another one that's weighted a little more toward the European ensemble. This one is weighted toward the Canadian ensemble, and then everything kind of put together. And you can see they all have some sort of closed low forming here over the northeast. And we kind of look at these to see if there are any big differences. In this case, there really weren't. Here's kind of the everything put together, and then here are the differences. So the European-led cluster was a little bit, stronger with the closed low. The Canadian was a little bit weaker, and the GFS was a little bit weaker as well. But nonetheless, it's interesting to see that each one of these solutions, cluster 1, 2, 3, or everything put together, were pretty much the same. There's not much of a difference. Maybe cluster 3, the European-led one, you can see the colder air gets a little bit farther south, but overall, they all have the same pattern. And that, this is 5 days ahead of time. That's giving us pretty good confidence that an Arctic air mass would rotate through and would pretty much be passing to our east overnight, Saturday morning. So the fact that this really wouldn't last very long. So again, looking at these clusters, it tells us, again, there's high confidence because each of them are fairly similar. And they're also pretty good agreement that this wouldn't last terribly long. Now, another thing we can look at with the same clusters is what's the probability of temperatures falling below zero that Saturday morning? So again, this is a 5-day forecast and pretty remarkable. Again, we're using the same clusters that we talked about on the previous. So the coldest you can see is probably this cluster 3, which is the European lead cluster, and it's got the deeper low, so it makes sense the colder air would be a little more entrenched to the south. But again, they're all fairly similar. probabilities, well over 50% for falling below zero. And this, again, is 5 days in advance. So to see those very high probabilities means there's very little difference between any of the ensemble members, and it leads us to high confidence in this event occurring. And just to close out here, this is the mean temperature. So again, the same clusters showing the same signal. Our cluster 3, the European lead cluster, is the coldest of all of them, but even it has essentially single digits down along the south coast. We know it got a little bit colder than that, but notice everywhere, pretty much where you're into the pink, it's below zero. So even down, to the Mass Pike on everyone put together was, again, below zero. So really, again, high confidence for a 5-day forecast. And just to show some of the winds, these were a little bit more underdone, which is typical at 5 days, but showing good potential for strong and damaging winds. What you see in the orange there is the strongest winds looking at about 50 knots or higher. Notice that's mostly over the water, over land. In this orange, it's 40 to 50 knots, but still showing you can definitely see the higher terrain kind of picked out, the Berkshires, hills of Worcester County. But showing, at least potential for 40 to 50 miles per hour 5 days out. And as we know, that got even a little bit stronger as we got closer to the event. So the other thing that we use in forecasting is what we call our national blend of models. And that's used for the basis for our day-to-day forecasts, and typically does very well day to day. When we get into an extreme event, typically we have to shy away from it because a blend will average everything together, the warm solutions and the cold solutions. So in a case like this, typically it's too warm. And you can see here on the right, these are the forecast low temperatures from January 31st, still cold, but obviously it got a lot colder than this. Now on the left, it's actually showing the range from the national blend, and this was on the January 31st run, the same one. So you can see, for example, it did hit at the cold. There was the possibility of getting down to minus 20 in Nashua. It got to minus 15. At that point, it showed the potential for minus 13 in Boston, and it got to minus 10. So you can see there was quite a bit of spread, and that's to be expected, several days out, with a range of about 15 degrees or higher, even 18-degree range here at Windsor Locks. But did show the potential for some serious cold on some of those lower range numbers. So as it mentions here, 80% of the time the temperature will fall between this given range. It pretty much did, but leaned definitely toward the colder side. So this is where the forecaster comes in and says, okay, it's giving you -5 at Boston. It's going to be obviously much colder than that. And the forecast can be adjusted downward for various locations. Now, just to show some of the wind potential, this was kind of interesting. We looked at some of the forecast soundings. And again, this is similar to what we showed from the gray main sounding. Temperatures in the red dew point is on the green. And what we look for in this gray area, this is our mixing level. So this is where the wind gusts can be transported down to the surface. And the higher the mixing level, the more wind you can mix down. So you can see in this example for Westfield, what we do is we look at the lower number as kind of a mean gust, which is 39 knots. But potentially you can mix up to the top of this, which would be 60 knots. So in this case, if you're looking at it as a forecaster, you'd say, okay, roughly I'm looking at gusts of 40 to 60 knots, or about 45 to maybe 65 miles per hour. In this case, the actual gust was on the lower, about in the middle, 48 knots, so not bad. But if we were able to mix higher in this case, it potentially could have reached over 50 knots. And this was looking, I believe, a few days ahead of time from this event. Here's a sounding for Worcester, showing kind of the same thing. Notice the mixing's a little bit deeper, but not into those purple winds, which are certainly strongest. We have a potential here for 33 knots on average, with a max of 51 knots. And the actual gust was pretty close, a little bit higher, 54 knots. So maybe, it did mix a little bit higher than what was shown here, but not bad, for kind of taking a guess at some of the gusts. And for Nantucket as well, did pretty reasonable. Average of about 40 knots and a peak potential for 55 knots. And the maximum gust at Nantucket was 52 knots. So works very well. And this can be found on BuffKit by looking at your transport. It's called the momentum transfer button, which is you can actually see right there. So if you have BuffKit at home, and again, it's freely available on the web, you can certainly use this to kind of predict wind gusts. It works pretty well. Now, as far as our messaging here, to emergency managers, we did a lot of these one-page briefings as shown here. highlighting the dangerous cold. And we began highlighting this on our weekly emergency manager briefing Monday morning, and just followed up with these one-pagers throughout the week, but really highlighted the dangerously cold wind chills, down minus 20 to minus 40, as well as the moderate to heavy freezing spray on the coastal waters, and just some of the impacts right there. So these were sent out about twice per day as we went through the week, and really was little change in the forecast from what we briefed on Monday and Tuesday. So that was nice to see that the models were fairly consistent with this cold air mass. And on social media, I'm sure many of you saw this as well. We started ramping that up the weekend before with the 8 to 14 day outlook, and gradually ramped up our messaging as well through that week. And as I mentioned, the model data really gave our forecasters added confidence to strongly really message the potential for the record cold, the dangerous wind chills and high winds, and some of the marine impacts several days in advance. So that was a win for the models in this case, and the ensembles. And as you probably remember, there was a dramatic 24-hour warm-up. We had a massive temperature swing take place on Sunday, February 5th. As you remember, the heart of the cold air was pretty much moved through on Saturday. So Saturday night, temperatures didn't drop very much. They actually stayed fairly steady. They got up into the teens and kind of hung there most of the night. And then Sunday morning, as the warm air really moved in, many places saw temperature rises of over 50 degrees in 24 hours, and many places topped in the coastal areas, topped out near 50 or in the low 50s Sunday afternoon. So definitely a dramatic change. People asked us, was that a record? And no, it actually wasn't. There were actually warmer 24-hour warm-ups than what we saw, closer to 60 degrees in some cases. And I don't have the dates with me, but this was certainly good, but not a record by any means. So just to summarize here, some of our key points. In highly anomalous situations or unusual situations such as this, expect that the model guidance that you're seeing will kind of underperform. So what does that mean? Well, things like the wind gusts, maybe precipitation amounts, or even storm surge for coastal flooding, they usually end up being too low from what you're seeing on the model output. So an example might be we have a highly unusual storm coming through, and that situational awareness table is kind of lit up all over the place. Well, if the models are showing you maybe a 3 to 6 inch snowfall, usually you can anticipate it being a little bit more than that. So it might end up being, a 6 to 8 or 6 to 12 inch snowfall. And as I mentioned, the model blends, such as the national blend of model, they don't always capture these extreme events because they're averages of things. They take the average of the high and the average of the low. So day to day, they're very good. But in these extreme events, which are outliers, usually there's one or two models that are right on it. Usually our high resolution models, and the blend will kind of be watered down a bit and not capture things like the strength of the wind, which it didn't in this case. So this was kind of a key points for our staff, always mentioning use science to add value. Don't just take the model guidance verbatim, dig into it, look at things like pattern recognition, the model soundings like I showed, and some of the diagnostics that we use just to really kind of see what's going on, because the models are good, but in these extreme events, they are underdone. And the other key thing is, when our 850 millibar temperatures get down to minus 35 Celsius, that pretty much guarantees below zero temperatures, even down to the coast and in the absence of snow cover. So I know snow cover is often talking about as a big factor, but in this case, it was so extreme that it really just didn't, really add too much to it. So now internally, I'll share this with you folks as well. We do an internal review of what worked and what didn't work. And we did have some good, best practices from this. Overall, the seriousness of the very cold weather was highlighted very well in our weekly emergency management briefing Monday, and in subsequent one-pager briefings during the week. So the message got out there and was acted upon by folks in the emergency management community. So that's a very good thing. We were a little weak on mentioning the strong and damaging winds. We were more focused on the wind chills and the temperatures. So we did have some questions from some of the emergency managers why we didn't mention the strong winds in our briefings earlier in the week. We didn't really start until Thursday. We knew this information because it would have been useful for preparation on their part, which makes a lot of sense. If they knew Tuesday or Wednesday, we kind of thought it was implied, but they really wanted to know, the winds separate from everything. So going forward, we're going to make sure we include separate mention of strong winds in these type of situations. Now, something else the staff did too, which was great, was making some personal calls, picking up the phone to our big city emergency management directors. So think Boston, Providence, Springfield, Worcester, Hartford, etc., and some of the others as well. Really just giving these heads up calls so they know that, hey, we've got the email, we've got the information, but no, this is something a little more unusual and something you really need to take seriously. So certainly for Arctic outbreaks like this, it's important. Certainly for like a higher end storm, it's important, or maybe even a tropical storm or hurricane, we would do that as well. So it just adds confidence on their part that, hey, this is something a little more unusual. They're calling me, so I really got to pay attention to this. And we actually had a bit of a national media blitz, believe it or not, on Friday. And we had a couple of people just kind of designated to doing media briefings. We actually not only had our local media, newspapers and whatnot, but we actually had national media, places like CNN, NBC News in New York, giving us a call because they knew Boston was kind of the epicenter and New England was for some of the cold. So they wanted kind of our take on it. And we had dozens of media briefings during the day on Friday. So having a couple of people available just to do that was really helpful for the rest of the staff and allowed them to focus on kind of the forecasting and the messaging to emergency managers. So that's something we're going to keep doing moving forward when we get into a big situation like this. So with that, I'll leave the summary up here and just with some of our points again. And at this point, we will pause and I will go ahead and look for any questions here. So I will do that. So let's see as I go through. Let's see. So Carrie wanted to know why we haven't had long-lasting Arctic air or seasonally cold air this winter. Well, a lot of that has to do with that subtropical ridge that I was talking about. It's been our dominant weather feature. We're in a La Nina winter. The last one, it's kind of going away now, but in some of the La Nina winters, that ridge over the southeast can a lot of times exert itself up here along the East Coast and really suppress the cold air and the Arctic air. So that's why we did have a couple of shots of cold again just before Christmas, and certainly this one, but really nothing prolonged because we've just been under the influence of really Pacific air for a lot of our winter. So let's see. So Joe says in Haverhill, it got down to minus 12, coldest temperature in 14 years of taking observations. Yeah, I believe it, Joe. That's pretty impressive. And a wind chill of minus 37. Nice. Let's see. So let's see. I see from Tom some sea smoke. Let's see. So let's see from Carrie. Carrie also wants to know, did our summer and fall play a part with perhaps the ocean not being able to be cold enough to sustain cold weather? Probably not. Good question. Did we kind of even out from, we had a fairly dry summer, so are we kind of getting wetter, over the winter? Yeah, I'd say probably. But overall with the general pattern, doesn't have too much of a role in it because our air is coming from the west, not so much from over the ocean. Let's see, from Tom, Boston's low temp, Christmas morning, 1980. Oh, you're going to stump me with that. I'll have to figure that out. I know that was a cold one as well. So if anyone wants to do a quick search on that and let me know, that would be great. Christmas morning, 1980 in Boston. I know 1982 or 83 was also a cold one. That was below zero. Let's see, from Catherine, was the lack of blocking high pressure the only factor as to why the Arctic air moved out so quickly? It was the main reason, but we're also, as you know, through much of the winter, we've been in a very kind of fast flow from the Pacific, so really wasn't anything there to kind of block and kind of keep things going. The one thing I've noticed this winter is there's been no ridge in the west, and that's normally what we want to get a lot of storminess and a lot of cold. It just hasn't been there. They've been in a trough, which has kept them pretty stormy. As you noted, you've probably seen all the rain and snow reports out of California, the Sierras and everything. They've been getting hammered with rain and snow, which is good. They need it. But unless we have a ridge out there and a big trough in the east, things are going to keep moving right along. So we'll get these glancing blows of cold, and that's going to kind of do it. Let's see, from George, during the Arctic air blast, my mother in Orleans, Mass, experienced snowshoes on the front end of this blast. Can you explain this further? Oh, let me see. Snowshoes on Georgia, I don't know. Interesting. Did they have, I think they had some snow on the front end of it. That's probably what happened. I know there was some ocean effect snows that occurred as the Arctic air moved in. So I guess, I hope, George, I hope that's what you mean. And welcome. It's good to have you here with us from Minnesota, as always. Love it. Let's see, from Brian. It seemed that 24 hours out, the different model performance was not great. Yeah, other than I think the European model, which got a little bit colder, the other models kind of relented a little bit. But we kind of knew, again, looking at the upper air pattern, that was fairly in pretty much good agreement among all the models that, it was going to be cold. We weren't going to be getting any quote unquote warmer with this storm. So yeah, there was a little bit of disagreement. Some of the high res models in particular, Brian, I know kind of let up a little bit. So luckily, our staff kind of just looked at the bigger picture and kind of ran with it. So that was good. Let's see, from Bill asking, what was the airplane effects of the cold? So maybe I'm thinking flight or effects to aircraft. Not much. There wasn't nothing noted. It was so dry. There wasn't any icing issues on the aircraft. On the ground. And even aloft, there just wasn't. There was some icing, but nothing overly significant. There was a lot of turbulence, though. I can tell you that over that weekend with a very strong jet stream. As the aircraft go in and out of that jet stream, it gets very bumpy. So there was a lot of severe turbulence over the Northeast during Friday and into Saturday as well. I think that was the main thing as far as aircraft. Jonathan, just as a quick question, where can I find the recordings of these webinars after the fact? Just go to our YouTube channel. So go to YouTube, NWS Boston, or you can go to our webinar page on our homepage that has the link there as well. But just go to YouTube and search NWS Boston, go to the video page, and you'll find them all there. From Bert, let's see, Sandwich, -9, one higher than the record. Yeah, even on the Cape, did pretty well down there, below zero. That's, like I said, that's pretty impressive when the Cape and the islands get cold. Let's see, Brian, temperatures ran lower than forecasted for the Euro, GFS, and NAM. Yeah, they did. They did run a little bit colder. But I remember the European model did trend colder, even though it was a little bit underdone as we got. I think it had a low of like -6 at Boston or -7. But it did trend a little bit colder. But yeah, they didn't quite capture the extent of the cold. From Katrina, is there a formula or calculator we can use to compute wind chill using personal weather stations? Yeah, there are wind chill charts online, Katrina. If you do a simple online search, just do wind chill chart or wind chill calculator. You should be able to find one pretty easily. They're kind of widely available out there. And from Joe, oh, thank you. Christmas 1980, the low was -7. There we go. Thanks, Joe. Appreciate the assist on that. It's hard when you're running these by yourselves. Can't always do a quick search. So there you go. All right. So that is all I'm seeing for questions at this point. So we will pause here. And what I will do is finish our recording.